Welcome back, everybody. So let's continue. I left this overview projected a little bit during the break. So these are the categories of Lego pieces. I'm going to be soon focusing on navigation and FLWOR and a few more slides before that. That I told you. Since we had the tutorial, I'm just projecting this once, arithmetics, logic comparison. The only thing I can repeat to make clear is EQ, NE, GT, LT, LEGE for the comparison of one value with one value. What I mean is one item with one item, or a sequence of one item with a sequence of one item, one at a time. So you need to use this notation right there. Division is div instead of slash. That's because the slash is used in XPath navigation. I will show you that later. IDiv is integer division. Yeah. All right, but you have the tutorial, so I'm just passing over this. If you use the regular symbols for equality, inequality, and so on, be careful. There is an implicit existential quantification in them. Very powerful. So whenever you write with an equal sign, something equals to something, in fact, you have a double existential quantification. It means does there exist an item on the left that is equal to an item on the right? Right. So does there exist an item on the left such that there exists an item on the right such that they are equal? Who is with me? Right, okay. So that I'm passing quickly. Very powerful to write shorter code. So whenever you want to check if there's a huge sequence of 1 million items, you don't have to iterate explicitly. You can just directly make an equal and it's going to say yes if one of them matches. Now, a few more words of the function library. I already told you the functions are basically everything that didn't make it to being an expression. Because again, you cannot have 1,000 or hundreds of expressions in a language. So for example, concatenation, well, that's an example actually. The concatenation is an example of function which at one point in the W3C working group, we just decided to make it an expression with this double vertical bar, just out of practical reasons, because we thought, okay, people do it often, so we're just making it an expression. But before that, you had to use concat instead of the double vertical bar. String join, very handy. You've all been there writing the code to concatenate with a symbol in between. And then how do you treat the last one to not add a comma at the end, right? We've all been there. But in functional languages, string joins just does it. I think even Python has it, these sort of things. Okay, but I'm passing substring, string left. You all know that. In fact, if you go to the spec, so this is the RumbleDB documentation that says some of them that are implemented. And then the W3C page short, this is one of the specs behind xquery and XPath functions. You see the whole list in there. It's only part of the list. You have mathematical function. You have functions that manipulate objects, arrays, dates, times to extract a year from a date, and so on and so on. Right. So a huge list. It's there for you, and you can use that. RumbleDB actually supports so far all the functions that are not XML, that are not tied to XML, because XML we are doing right now. Anything that's not XML, it implements it. We just didn't implement all the flags, because some of the functions have flags to fine-tune the behavior, and that we didn't implement every time. But other than that, we support all the functions in the standard. This is a W3C standard, again, as you can see from the URL. That's another example of function library for Spark SQL. As I said, there's almost always a function library in any language. And in Spark SQL, you also have a page somewhere in the spec that has the whole list of functions that you can use, right? It's a must-have. If you design a query language, you cannot not have a function library in it. All right, that was it for the function library. Just wanted to make you aware of it. Maybe I could also add that functions are a good starting point when you experiment implementing a new feature that is not standardized yet, and you just came up with an idea of designing new features. It's usually a good idea to start with functions because you don't have to bother with the grammar yet. And once you have the functions implemented, then you can promote them to expressions and then define a grammar based on the experience that you accumulated using functions. All right. By the way, some examples of design that made it into the spec was designed at ETH. There was, for example, the tumbling and sliding windows were actually designed at ETH and then made it later into the W3C standards. Okay, next category, navigation. Navigation is something that didn't exist really in SQL because in SQL it's flat. Everything is flat. You don't have nestedness. But in the NoSQL language, like SQL or JSONic, or any one of the 30 other languages, you need to navigate into the objects in the arrays, in the objects in the arrays. You need to go inside and navigate. This is why we have a syntax that allows that. I'm going to tell you on the high level because, again, you have the tutorials. It's basically often going to be a chain like this when you want. And the more nested it is, the longer the chain, but you don't have to do lateral view, blah, 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 blah. You just concatenate things to your chain and that's it. Very, very simple. So in that case, JSON doc opens a single JSON document that might be on multiple lines, just one of them. Dot countries is going to basically go here to this array here. Dot countries, then this opens the array. So this array of with five members in the array becomes a sequence of 5 items because we opened it, like here. Then this is a filtering expression. It's a predicate. You use the square brackets. It's a predicate that filters specifically for the code to be equal to $. $$ is just the placeholder for the current item being evaluated. The first time, this is $$. The second time, this is $$. The third time, the fourth time, the fifth time. And if you evaluate $$.code here, you find $. As I told you, it's an existential quantification, but here it's an overkill because the existential quantification, there's only one object on the left and on the right, right? Because you're doing one object at a time. But still, some people do it. They still use the equal instead of EQ. The reason is that many engines figure it out. They are able to see that it's an overkill, and they will actually, during the optimization phase, replace it with an EQ, right? So this is why you might still see that. But anyway, we compare each one of the 5 one by one because, again, there's an iteration. The $$ is not the sequence of all 5. This is evaluated 5 times, once here, once here, once here, once here, once here. It returns true, false, 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 and false. And as a result, we only return the first object, which is this one. And then we say .name, and we are in Switzerland. Who followed? Right? Very good. So now it's very powerful. The ancestor of this was actually XPath, created already probably more than 25 years ago now. It was navigating XML, but again, you know, XML and JSON are trees, so it's the same idea. So here you have object lookups, array unboxing, array lookup, and filtering predicates. You can chain them in any way you want. It's a Lego game. But specific aspects I want to emphasize is that this works seamlessly over sequences. You could have here a sequence of 1 billion objects, 1 billion objects. This is going to do this on every one of the objects, returning again a sequence. And then you do this on every object, you return a sequence. Actually, it's going to be a sequence of arrays, probably here. Then you open it, you get another sequence, maybe of objects here, .foobar. So you just keep going on a sequence, and at the end, you just get yet another sequence, right? So this is how you filter and navigate insights. This is designed to be intuitive. Another thing that's designed to be intuitive is what about heterogeneous sequences? What if you have huge sequences with arrays and objects and values and so on, because the data set is heterogeneous? Well, it's not a problem because whenever you have an object lookup with .foo, for example, it just ignores and drops whatever is not an object. You're not even getting an error. So the moment you say .foo, it's implicitly filtering the objects. The moment you open an array, it's implicitly filtering only the arrays. Right? So this is designed to be very intuitive to use. And imagine doing that on millions or billions of items in a data set. Very handy. Who is with me on that? Right? Very good. Just to show you a few other examples. So JSON lines, unlike JSON doc, which is a single JSON document, JSON lines is 1 per line. So that can be billions. Another example is XPath. I said I would show you. So it's just /// instead of the point, right? It just a slash goes to the children element. You have, I don't know if I have an example. No, I don't have an attribute. The attributes use an arrow-based sign. You do @name would be the attribute called name, right? You have this same predicates here with the slash. the dot in XPath is not $, it's dot. Dots like actually it's similar, that's why it's called XPath, similar to the dot on your file system. That is the current directory. Dot actually also works in XPath. You could go one level back and so on. But the reason we have $, here is that the dot is already used for the object lookup, so it would collide. So that's the main design change reason in JSONic. That is XQuery, XPath. Here's another example where we read a JSON lines file from HDFS, right? Again, the language works everywhere, so all you have to do is specify, assuming you have access, of course, the HDFS URI of what you want to query, and it just works in the same way. Here, it's an XML document store. Imagine that you've bounced the language to a document store like ExistDB, and then you have this collection function in XPath, followed by a predicate, / and so on. /data just extracts whatever is in there. So if you say name /data, that's, sorry, I cannot reach it somehow. It's going to take Switzerland right here. Okay, who is with me? Right, very good, okay. And this is very handy also for discovering data sets. Here you have a data set, you're getting all the keys. That could take a while, but it's all parallelized on Spark. So imagine you have 1 billion items. It's just giving you all the top level keys. You might explore also the distinct values. Actually, Pandas does that also, right? You have ways to do that, but this works on billions or trillions of items. By the way, if you don't have enough with Git Archive, which is dimension for the exam, so it's not too big, you can download plenty more to push the limits because there's one file created every hour with all of GitHub data. I actually tried it on a cluster once just to show you. This I got in real time. Probably took 30 seconds or something from this. I had a lot of machines. Then I instantly shut them down to not make ETH unhappy about the costs. But just to show you that this also works on a cluster of machines with more data. All right, so I went faster compared to previous years because again, you have the tutorial, you can experiment, and I want to focus a bit more on some design aspects. Any questions so far? Yes, over there. Oh.
Sorry, I didn't quite understand the behavior of the operators when the inputs are sequences. So if I do A plus B, for example, and A and B are sequences, or if I set 2 attributes in an object to sequence values, like what will that result to? Is it like a join or
an error?
Each with each?
So if you do, I skipped that because I put it in the tutorial, but the idea is that plus or generally arithmetics logic can only handle 0 or 1 item. The moment you have more, that breaks. That's an error. So these are local operations. And in fact, this is exactly the reason why in RumbleDB, I will say a few words later, we implement them locally. So the plus is implemented as a simple method call, for example, while the navigation that you saw is implemented with RDDs, map, flat map, filter, as you can imagine, right? So whenever it's large sequences, you can use transformations for the physical implementation. Whenever it's small sequences, you just do it in memory. And so it does mean that in the language, some expressions always return exactly 1 item. That's, for example, what happens with plus. It returns only 1 item. And some expressions only accept at most 1 item as input, and otherwise will break. So if you want to add a lot of things, you just need to iterate with a for, as I will show you now with FLWOR. Then you can add a lot of things together. Right. With a double for, if you really want to do a join and have the complete multiplication or addition table, you can do a double for, and like for $A in 1 to 10, for $B in 1 to 10, return $A plus $B. That does the trick, right?
Okay. And if I like do an object literal and I set 2 of the attributes in the object to sequences.
I didn't get which literal?
And like an object literal.
Oh, an object literal. So let's get back. Yeah. So that would be the ones where you copy paste it, right?
Yes.
Yeah.
But the expressions and the values could be sequences, right?
Yes, absolutely. Yes, absolutely. Even on the left, but on the left for the key is going to be an error. If it's not exact, it has to be 1 on the left. If you have a sequence on the right, we had a lot of discussions about that, but basically what it does is that it nests it in an array. So it's going to take the sequence and create an array whose members are the sequence, the items in the sequence, but then it's an array, becomes an array. And the reason is we cannot nest sequences.
Yes, okay. Thank you.
Yeah. It's a discussion because there's 2 designs actually. There is an alternate design, and actually the one that later was standardized on the X-query side, which actually does allow values to be sequences. The reason we didn't do it in JSONic originally, and we argued against it, is because you cannot parallelize that so easily on clusters. You can parallelize easily if the sequence is the outermost construct. When you have sequences inside, it's more complicated to implement. Imagine the sequence has 1 billion items. Then you can no longer implement this object that has at some point 1 billion items inside physically as a simple small objects in Java, right? Then you have to have at the place where there is a sequence, you need a pointer to an RDD or to a data frame or something like that. But since it was standardized in this way, and we are going to align in the standard a bit later, we will think how we implement it. It's actually maybe a cool challenge, try to figure out how we can also then support objects that would have nested sequences with billions of items, right? So future work. So as you see, it's a discussion, right? So there's that's a design decision is made at that point on what to do.
Right? Okay, thanks. Okay?
Thanks a lot. Very good question. Other questions? On Zoom? Anybody on Zoom? Don't see anybody. Yeah, all right. Who is with me at that point? Okay. And please do the tutorial. I really recommend everybody try to do the tutorial, because I'm not going to show you everything that I used to show in the lecture. So that's my recommendation. Where were we? I'm just trying to find, yeah, that's a lot of slides that we did, and we stopped at FLWOR, I think. Yes, here. All right, so let's continue then. FLWOR expressions are probably the most powerful and distinguishing feature of these languages. This one is also a W3C standard, the FLWOR expression from X-query. It's probably now 25 plus years old. The reason it's called FLWOR, can anybody guess actually why it's called FLWOR? Yes? So from the keyword, so yes, it has to do with the names of the clauses. So this would be SQL, this would be a JSONic or X-query. So do you see the FLWOR in the clauses? So you're completely right that the FLWOR expressions correspond to select from where. Does anybody see it? Do you see the FLWOR? Yes? Yes, exactly. For, let, where, order by, and the R is return. Exactly, that's where it comes from. You see, for, let, where, order by, return. I think it's probably also in honor of one of the early inventors of the language, Dana Florescu. So maybe it was also made in her honor as a pioneer. But many more come later. We didn't have group by at the time, right? So you have group by, counts came also a bit later in the spec. So this is the idea. In any case, you were correct that the FLWOR expressions correspond to the select from where in SQL. It's pretty much what it does. But I will now do a bit of a comparison. So I added all these slides new this year. So let's compare them so that you get the idea of how they differ. The first thing that I should mention is that the people who designed these 4 clauses and standardized them, so Dana Florescu at the beginning, then many other people in the working group at W3C, these were SQL designers. A lot of these people were also the ones who designed SQL. The chair of the working group, Jim Melton, was also himself a SQL editor. So basically, you had all of this expertise from SQL, all the limitations that they were aware of, came into the design of the whole language. So that's just to say that there was a lot of experts of SQL that took part of it. Now, among the things that they flexibilized, here, the fixed order of clauses. You know that in SQL, it has to be select from where, group by, having, order by, limit offset. You can't swap it or put it in any other order, or you would have to nest clauses. But in JSONic, it's different. In XQuery and JSONic, that's a W3 standard, so that's also in XQuery. You see here, for, where, let, group by, let, where, order by, count, where, return. It's really generic. You can put them in any order. You have a where here, you have a where here, you have a where here, you have a let in the middle here, a group by. So it's completely flexible. There's just two conditions. It must start, the first one must be a for or a let. That's condition number one. And the last one must be a return. That's condition number two. In between, you can put whatever you want and in any order you want, of course, assuming that makes sense to what you're trying to do, but you can really put them in any order. So anything in between this and this is anything you want. You could imagine even a flower clause with a flower expression with 100 clauses, if you want. I actually saw some sites by companies where they did have 100 clauses in a flower expression. Right, so this can actually be done in this way. So you see, we flexibilize this. It's more flexible. We can have them in any order. All right, who is with me? Right, very good. Second, number two, there's more clauses that did not exist in SQL. The let clause, for example, does not exist in SQL. You could argue there's with in SQL, so to some extent it does a bit of what the let clause can do, but the let clause is more powerful because the with clause in SQL can only be outside before the select from where. Here you can have the let clause even in the middle, like any other clause. So it's extremely powerful because first you can let, I will have a slide for you in a moment. A lot of people like a sequence of let clauses. Let, because it kind of emulates the thinking of imperative programming in the sense that you just have assign variables, but it's still functional. You don't actually modify anything. So people like to do that, to use lets in order to have shortcuts and go in their thought pattern with the values that they assign. But it's also very nice in the middle of a query to not have to write, for example, you don't want to write count every time, you just give it a name and then you use it, right? So this is very, very convenient to be able to do this in the middle of a flower expression. Who is still with me, right? So we have others that are not the count clause. The count clause is just assigning depending on the position. So this variable in the first time, I will tell you more the mechanics later, but it's 1 and then it's 2 and then it's 3. So in the end, you have the position where you are at in the output you're generating. And then you can filter based on that position. And that basically gives you the behavior of limit and offsets in this way. Right, so I think this is the reason why they didn't put limit and offset when they did that, because you can actually use the where clause in this way and the count clause together to do the same. So this is why they opted out from having limit and offsets. Then we have also, as I told you, this was at ETH, sliding windows, tumbling windows. You can stream through the sequence. I'm not including that in the lecture because that's a research field and could be an entire course of its own, how to do stream processing with the starting conditions, the ending conditions. Who knows stream processing a little bit? Maybe some of you, yeah. So basically this can be done with sliding windows and tumbling windows, but it's not the focus of RumbleDB, so we haven't implemented them yet, but that could be an idea. Another aspect is that the order of the clauses that you see on the right is actually going to be, in many cases, because the optimizer can find better way, the flow of Spark transformations, because we implemented it on top of Spark. And basically, when you do it on top of Spark, you let the RDDs, actually it's data frames, so you see why later. So you create a data frame, and then you create a data frame, you create a data frame, you create a data frame, you create a data frame. Every clause just takes the previous data frames and generates the next one. And at the end, you evaluate to a data frame or an RDD. So it means that the order of the clauses in there, in the design of the language, is in the same order as you would expect Spark transformations to take place. I'll have more slides to show that to you. In SQL, it's not the same because the select from where, so the select is the return. So you see the return here is at the end, as you would expect, but the select in SQL is at the beginning, right? So you could also have imagined from where blah, blah, blah select, but then it wasn't in the spirit of the English style of SQL. There was consideration at some point by some members of the committee to move over the return clause to the beginning and to call it select in order to make it a bit more smooth for people coming from SQL. But in the end, it was never done. It never catched on. And in fact, precisely because it has the natural flow of transformations, this was kept in this way. In fact, it's rather the other way around that now people in SQL actually are modifying SQL to obtain this effect of being consistent with the flow of transformations. Who heard of the pipe syntax at Google in BigQuery? So the pipe syntax modifies SQL in a way that you have the SQL clauses chained with each other in the order of the Spark transformations, or in that case, Dremel or whatever system they are using now. So you see that this idea is very powerful and did flow into other products in this same way. Okay, everybody's still with me? Okay. The next one is that in SQL, the select from where can be nested, but not everywhere. You can only nest it at a few places. You can nest it in a from clause when you give it a name. You can nest it in a where clause, for example, where some attribute in, and then you have a select. So it's a bit limited and restrictive how you can nest them. But since JSONic and XQuery are a Lego game, the FLWOR expressions can be nested absolutely anywhere. Anywhere you would expect an expression, you can also put a FLWOR expression. You can even put a FLWOR expression inside a plus, as long as it returns in the end only one value. Right? You can also nest it inside absolutely anything. All right, who is still with me? Very good. Next one. Who heard of correlated subqueries? That's an advanced, super advanced feature of SQL. I don't think I see any raised hands. Anybody hand higher if you know it? Okay, really, okay. So a correlated subquery is basically when you, so typically when you nest a select from where inside, for example, you nested inside a from, or you nested inside a where clause, like where this attribute is in this, and then you have a nested select from where expression. Normally, in the standard SQL as it was before, this nested SQL query could not depend on the record that you're currently analyzing from the outer select from where. So it means that the nested select from where would be evaluated just once independently, and then you use it in order to analyze the outer select from where, right? So I repeat very formally, in the older SQL specifications, whenever you nest an inner select from where query inside an outer select from where query, the inner select from where query does not depend on the record that you're looking at in the outer query. It doesn't depend on it. Later, some people started seeing that it could actually be useful to let it be actually dependent on some record, on some attribute of a record, and that is called correlated subqueries. In fact, in JSONic and XQuery, you get it naturally because since you can nest a FLWOR inside a FLWOR, if you have a FLWOR expressions inside a where inside a FLWOR, the FLWOR expression that is inside the where clause can depend on anything it wants. All the variables, basically, if you would have, let's say, a nested expression here in that where clause, you can use in that nested FLWOR expression all the variables that are before. Every variable here is in scope, and you can use any of them in your nested FLWOR. And it does mean that your nested FLWOR will be evaluated for every combination of variables. So be careful, because if you have a billion here and a billion here, you might have to evaluate this one a quintillion times, I think. So be careful, right, when you have this correlated in this way. But basically, it means when you nest FLWOR inside FLWOR, you have the right to use and read and depend on every variable that comes before that is in scope. Who is still with me? Right, okay. Then just a slide to show you what I meant before, that many people are big fans of let. So this is what it looks like. They basically chain the lets, even without any for or anything, just because it's convenient and easier to read, right? So here you take a file, you open it, you navigate to actor, you navigate to login, you take the distinct values and you return the count, right? It's just for the chain of thoughts that some people like that. Okay. Then I want to show you a difference with SQL on the group by clause. Who remembers the SQL group by clause? Very good. So in the SQL group by clause, you might remember that you have grouping keys, the one that you put in group by, and you remember that every other attribute that is not a grouping key has to be aggregated if you want to use it. You can aggregate it with count, with sum, with max, with min, but it has to be aggregated. It doesn't make any sense to write a SQL query leaving an attribute that is not a grouping key in the projection of the outputs. Who remembers that? Right, very good. But the beauty of NoSQL is you're not restricted in this way anymore. So it means that when you group by here by continent, so I picked my value continent from the field continent in here. Where is it? Oh, I don't have you can imagine the original data set because that's the output. So you basically have a list of 200 countries, let's say, and then for every one of these countries, you take the continent, you group by continent. And look what happens, because that would be the select in SQL. So using continent, that's totally normal. We do it in SQL too. But look here in countries, I'm using something that is not grouped. So what happens, that's the mechanism in XQuery and JSONic, is that everything that is not grouped, so here we group by continent, $X is not grouped, so we make it into a sequence. All of the bindings to $X in the same continent, in the same grouping key, become a sequence. So it means that the moment you group, if you take one group, let's say North America, $X will be the sequence with the object for the United States and the object for Canada, and then .name is going to extract the strings, you see, with the lookup, and then it creates an array. By the way, to come back to your question, if I had not put the array in here, then that would also have created this array, because it's more than one value, right? So this is an example. And so you see, we did not have that in SQL. In SQL, we were not allowed to just accumulate all of the values within one group, because it's flat in SQL. You cannot nest in any way. But here we can nest because we have arrays. We have arrays, and so that means that it's absolutely no problem at all to have these smaller sequences that are for every one of the groups, and we can use them to create substructures, nested arrays, nested objects. Who is with me? Right? But of course, you can still aggregate. You can have count, sum, max, min. They still exist. Then you just do it on what you want to do. You could have, let's say, $X dot population, and then you have the sum of that. So some function called sum $X population, right? So you can aggregate also. So this is another way where the group by clause is more generic than in SQL. Just so you get an idea, I would like to give you the formalism behind the FLWOR expressions, because for many people, it's just intuitive, so they don't need to go through this. The implementers need to go through this, but it's actually good to understand, because then you also understand how it's implemented in Spark, this thing. So the idea is that when you have a FLWOR expression like this, you go clause by clause, because I told you it's in the order of the transformation. So you start with the first clause. And what happens is that every clause is going to generate not a sequence of items, because these are not expressions, these are clauses. They're a totally different animal. Is going to generate bindings known as tuples. So it means that when you say for $X in 1 to 10, it's going to generate 10 bindings for $x. X equals 1, X equals 1 the first time, then X equals 2, and so on. You can visualize this as a data frame with one column called X and all the values, right? And the idea is that it's a for loop, so everything that happens next will go iterating over all of this. Everybody with me? Right? Then we have the where clause that takes this as a starting point. We have an expression here, and this expression is going to be evaluated 10 times. Remember what I showed you earlier, telling you a sub-expression could be evaluated multiple times. So here it's a sub-expression of the FLWOR expression, and this is going to be evaluated 10 times and leading to 10 results. As you can imagine, so this is basically $x minus 2 greater than 5 is the same as strictly greater than 7, right? So for 1, 2, 3, all the way to 7, it evaluates to false, and from 8 to 10, it evaluates to true, right? By the way, who sees it's a map transformation? Right, that's basically what it is. So we have a map transformation, and we can use this as a filter. So in fact, we can even directly use a filter transformation with the same predicate and directly arrive to the filtered values. So the where clause can either be seen as a map transformation, and then you could do what's a zip to then extract only those you want, or you can directly filter by evaluating that predicate that is right here, over here, and then you get these outputs. So it means that after the where clause, there's only 3 bindings that survive: X equals 8, X equals 9, and X equals 10. All the others were filtered out by the where clause. Who is with me? Right, very good. I'm very cautious on the progression. And then the return clause, it's now the end of the expression, so that cannot return a binding anymore, because that's the end of the FLWOR expression. And since the FLWOR expression is an expression, it has to return a sequence of items. So what is the sequence of items we return? Well, we calculate this, 64, 81, 100. That's a map. Again, actually, it's a flat map, more precisely, because if this returns multiple items, it's flattened again. So we can apply a flat map. And then we get basically a sequence of these 3 items, which in Spark could be a data frame or an RDD. That depends if it's homogeneous or heterogeneous, but I will tell you later. Who is still with me? Right, very good. I have a few minutes left. Now, let's see another example. So again, the for loop we already saw. So that's it creates these bindings, 5 of them. The let clause is basically extending the bindings with a new binding to Y. You could see that as a data frame with a new column, where you have now X minus 2 is computed in real time. That you can actually do with Spark SQL. So internally, we actually do use Spark SQL and or the data frame transformation API, which is also sometimes very convenient to do that. But logically, we basically just have new bindings. So it means that we have still 5 bindings. In the first binding, X is bound to 1 and minus Y is bound to minus 1. In the second binding, X is bound to 2 and minus Y is bound to 0, right? Which allows us to evaluate the return clause as you just multiply row-wise, minus 1, 0, 3, 8, 15. Who understands how this, where this comes from? Very good, right? So now you know how the let clause is working. It just adds columns to the data frame. AKA, we add a new variable binding. Now group by. So the 4 we already saw. So in that case, there's just 5 different bindings. Now the group by here, it's actually a fancy shiny group by that also has a let inside. It's at some point, some people figured out that in order for not people to need to write let and group by, you can directly assign in the group by. But anyway, we could also have done it with a let. But in any case, that creates a $y column in here, modulo 2, so the even numbers are mapped to 0 and the odd numbers are mapped to 1. And when we do the actual group by, you see that this is the behavior I told you earlier, because we are grouping by $y. This is my grouping key. So it means that I have 2 groups, the group with the 1s and the group with the 0s, right? So I have a group with the 1 and the group with the 0. And now you see the effect on the group by on the other variables that are not grouping keys, because it creates a sequence. So we have here the sequence 1, 3, 5, and here the sequence 2, 4. And then with the return clause, for each group, you see here I'm using count. I told you can also aggregate. So I'm counting how many there are. There were 3 of them. That's the count of that sequence. It's a function called in the function library. And 2 of them in here. Who understands that query? Right? Seeing it like this is a bit more intuitive for the group by, because if you don't visualize it, figuring out what the group by does on $X is not necessarily straightforward. So this is why it's good to see it like this. I would like now to show you joins, because selection, projection, and so on, you basically already know how to do it, right? So the selection, you use a where clause. And for the projection, can anybody guess how we do a projection? Yes? Yes, in the return, absolutely. There's 2 ways actually in the return. First way is you use an object constructor with exactly the keys that you want in your outputs, and then you assign the values. And second, there is also a project function in the function library that is going to do the projection to the keys that you want. Right? So that's absolutely correct. It's in the return clause. Group by aggregation we've seen. Order by, it's intuitive too. It just reorders the bindings, the order in which you do the evaluation of the return clause. So let me just show you the joins directly. So imagine I have these 2 very simple collections. They could be nested, by the way. So here we are going to denormalize them rather than normalize them. So imagine I have a collection of products and a collection of stores, and my products refer to the store. So here, this store 1 is actually Switzerland, store 2 is Germany, and so on. So we want to join them. Well, joining is similar. You know that in SQL, you can either join using the join keyword, but you can also join by just putting 2 tables in the from clause with the joining predicate in the where clause, right? Because the optimizer will figure out that it doesn't need to compute the Cartesian products. Who remembers that in SQL? Right. So either you use the join keyword or you have 2 tables in the from with a where. Well, in JSONic and XQuery, FLWOR expressions in general, you do it in the same way. You have the where clause that has the join predicate, and you just have 2 fors. So you iterate a product of stores. At that point, you basically would have the Cartesian product, but don't worry, because a good engine will detect that it's actually a join and actually physically implement it as a join on Spark. And that's what we get right here. Who is with me? Right, so this is how you do a join. What about a left outer join? A left outer join means that you might have things that don't match. For example, you might have some type of product that doesn't match any country. You do that with allowing empty. Allowing empty will basically, if it iterates on this and it's the empty sequence, then it's not going to just drop the bindings completely, as it would otherwise do. It's going to assign the empty sequence to $S for that particular value of P that didn't have any match. That's basically a left outer join. Who is with me? Right, very good. And something that you can do, I think that's probably the last thing I'm going to show you before we go, is you can use joins in this way to denormalize your data. And that's the feature of NoSQL. So you have the stores, you basically bind to the products. I'm using let here, not for. So $P will be the sequence of products that match the store. And then I use this $P and nest it in there. So you see, I denormalize the data because I nested the product names inside the stores. So we are basically below the first normal form when we do that. So you see, you can join to denormalize even below the first normal form, whereas in SQL, standard SQL at the beginning, you can only go to the first normal form. Of course, later there was extensions. All right, any questions? All right, I think you deserved to leave. Well, you deserve, because I feel like you understood what I'm telling you. So I'll see you tomorrow at 9 o'clock in the morning, as always, and then I'll continue talking to you about query languages. Thank you.